Good day, hello and hi everyone, day 16 Rust. Let's go! This time around we've got a map, we've got some valves that we can open up and release the pressure. We're actually in the volcano, by the way. So we want to open the valves so we can release as much pressure as possible, and that's our job. So we have this sort of input, and as you can see, for one particular valve we have the flow rate, which is, as you can imagine, how much pressure this valve can release. And we also have whatever tunnels we have to other valves. Traveling to a valve takes us 1 minute, opening a valve also takes us 1 minute, and we've got only 30 minutes before everything explodes. Yep, our job is to find out perfect way to release as much pressure as possible within those 30 minutes. On the one hand, we are looking at a tree with pretty much a graph of wherever we can travel to. On the other hand, we are looking at a traveler salesman sort of problem or algorithm here. However, those two are still a bit different because we are still operating mainly on that pressure. So the pressure is the most important thing in here. My first impression, yes, pun intended, was that we would be looking into any valve that we can open. The biggest valve in here is H. It will release 22 air units or whatever per minute. However, if we have to travel to it for 5 minutes, then we are releasing that 22 units only for 25 minutes. Or actually 24, because we not only have to travel to it, but we also have to open the valve. What I thought would make sense would be to calculate which valve we can go into and how much air pressure can that valve release for the remainder of the time. I quickly realized this is a wrong approach because it doesn't give us the good outcome. So we had to change it, and we've changed it to sort of a brute force. Let's check it out. In terms of reading the input, there's really nothing special in here. It's kind of hard-coded, so it's not the most beautiful code in the world. It's certainly not the most flexible code in the world, but it is what it is. It works, so I'm kind of fine with it. That's it. Directions module contains everything else. Before we continue, one more reminder. I'm a Rust baby. I have no idea what I'm doing. I don't understand borrowing yet. I'm trying my best, but it's a long way to go, so bear that in mind. Please bear that in mind. For example, whenever I've got strings in here, that's mainly because I don't really know how to borrow them correctly, so I'm copying them over and over again, so it's not efficient at all. It is working, so I'm happy with it, but I really do want to improve that. And yeah, that's coming later. Let's take a look at the code currently. Alright, let's cover paths to valve next steps. So what we have is paths that we already traveled with. We also have the target valve, or whatever we are trying to go to, and we also have the map. So the map, you can probably guess, this is something that will repeat through much of the functions because it does represent the whole map already built in our memory, right? So it already covers which valve can connect to which valve and so on and so on. So this is just this having built in. We are getting the very last valve, so the current valve. Then if by any chance we actually have the target valve, we don't have to calculate anything more, we can move on. We probably could remove that. Let's check it out. Now I'm curious. Yes, it does work. Alright, cool. So yeah, fixing on the fly, as usual. Why did I remove this? Because I do know and I do remember I'm actually filtering that out later down the line. And exactly, this is where we filtered this out. And now we can really easily understand that this function doesn't really look at the target valve. It actually covers all of the tunnels. The one thing it doesn't allow us to do is to go back. So if we are walking from A to B, we cannot go from B to A again, because it doesn't make any sense. Alright, what else do we have? Now we have something interesting, because we have best path to valve. And this is where the target valve is actually useful. So what we do, we are looking at the current position, and this is a string, so this is only a valve name. We're also looking at the target valve, once again, valve name. We go with while, and using that path to valve next steps that we just covered. If anything already reached target valve, then we're golden. Since we are only working with valve names in here, we don't really care what path we take. So if there are 4 valves that are connected in this sort of diamond shape, so whether we take this path or this path, it doesn't make a difference, because it's the path of the same length. Those two functions that we were looking at are not focused on opening the valve at all. We are solely focused on finding a way from current position to the target valve. Then we've got a function that covers any possible targets. And this is actually very simple, because we are looking at valves that are still closed and have a flow rate more than 0. That's it. This to owned you can do without, because this is the copying of the string. I will try to figure out how to change that, but not today. Alright, what else do we have? So we go a step further. We are not only looking for the path itself, we are also looking for the action of opening the valve. First we cover a stop, because there is a possibility that you open everything that was to be opened. However, if your last input was either opening the valve or moving, then we are looking into the next step. If there are no more targets, no more valves to be opened, you add finished state on top and move on. If there are, however, some next targets, some valves to be opened, for your current position, you are looking into how to get to any of the targets that we still have. We could return in here the whole path, so from this to this we go 5 steps and return 5 steps. We could do that. However, part 2 actually breaks this sort of functionality, because in path 2 we really need to go step by step. You'll see that in a moment. Bear in mind, if we are at the target position D, and we want to actually target once again D because we want to open that valve D, that is still possible. And then you can add open valve action. Then what we want to do is get rid of duplicates. The important part is we sort it, then we can remove duplicates. Then we are looking at a struct that will help us out in here. All the steps that we took till the current point. Then we also are having the copy of the map, and this is important. If we take different steps, then we open different valves. So we could separate in the future from the valve, is it opened or not, and hold that in a different collection. We could do that. Then we also have the pressure released. It's easiest to calculate that based on each passing minute, so that's what I did. And also the pressure being released, because I didn't want to go through all the valves that are opened for this particular map and sum it up, although it is a valid point and you could certainly do that. Alright, and this is the actual logic, and this is gonna be hard to explain because it's still a little bit in shambles. I want to improve that. So for all of the minutes, we calculate the next steps. For each of those then, we are cloning the map, we are getting the pressure being released. If our last step is actually opening the valve, then we need to, first of all, mutate the map to actually have that valve opened. And the second thing is we are actually increasing the pressure being released. So what we are returning is, well, the new steps, cloned map, the new pressure being released. So this is calculated, let's call it, before actually opening the valve. Imagine that those moves can grow quite rapidly. And we also can have the moment where moving from A to B and then to A without any opening in between. At the end, we are also sorting the moves by the biggest pressure released, and then we are like retaining only maximum number of items. So this stops all moves from growing indefinitely. Now part 2, because that was too simple, right? In part 2, you've got a friend. You've got an elephant that you can teach how to open the valves. So you take about 4 minutes teaching him, and then you are left with 26 minutes, but you both go separate ways and you open different valves. And the question is, can you really release more pressure this way? The answer is yes, yes you can. Alright, how does that change our solution? And you can imagine now why that going step by step was so important. We're gonna be covering the steps in, or rather the paths that you go through, well, for 2 actors, for 2, well, not really people, because that's you and an elephant, but 2 actors. We build the next steps for you and the elephant, then you combine those next steps. And combining the next steps is really, well, you take all of the possibilities that you have times all of the possibilities that the elephant has. So it's growing exponentially faster than before. So whenever you combine those next steps, you can process them very similarly. Then we take a look at last step of both paths separately, and if any of those is opening the valve, we need to adjust our map and also adjust the pressure being released for the future. You can probably see, apart from this, we're looking at something extremely similar. Once more, we are filtering the case where we go from A to B to A without opening anything, but now we have to do that for both possibilities, for your path and also for the elephant path. So you can see here and here pretty much the same code. This is something I can improve and will do, but not now. And that's actually all the changes, because you still sort by pressure released, and you still hold on to 500 paths before you move on. What I want to underline is the solution is far from perfect. So I don't understand really how to handle strings and their lifetimes. So this is the first thing. Second thing is the solution itself. There's a lot of repetition of the code, and I'm sure I can minimize that. So there's still work to do here. And lastly, this thing. So max items. I am using 500 for this, and you can probably imagine that's not a random number, but then again, it's undeterministic. I used 500 because it works. I also used 50, and it works for part 1. But for part 2, well, it doesn't. So 500 is, well, it works, but it's sort of a guess game. So I'm not happy with that. And what I intend to do is improve those items as much as I can. And probably that improvement will be our next episode. We'll see. Thank you very much, guys. I'm happy you've been here. I'm happy I'm writing Rust. It's kind of fun. And as always, we can do better as a pack. Bye. So the biggest valve in here is actually H. It can release 22 pressure points, 22 air units, or alright, you know the drill. Now we are translating those paths that go I have no idea how to say it. The interesting part is we are releasing... Okay. And I don't have any very fun examples, unfortunately. Damn it!